Okay, now we come to matrix multiplication. Matrix multiplication. Let A be an m by n matrix. That is A. A is an m by n matrix, and B is an n by p matrix. Then the product AB, that means we are multiplying A with B. A comes first before B, is m by p matrix with entry A, B, I, K given by this. Okay. So if the number of columns of A is not equal to the number of rows of B, then the product is not defined. So in matrix multiplication, one thing is very important when we want to find matrix multiplication. The number of the columns of A, because A is the first one, must be equal to the number of the row of B. That is very important for matrix multiplication. If that is not satisfied, then no multiplication can be done. Okay, in our case here, we see the size of A is m by n. The size of B is n by p. So you see, we represent the columns of A by n, and we represent the row of B by n. So they must be the same. And then by the time you multiply them, it's like these two cancels out. So by the time you multiply them, the answer you'll be getting will be m by p. That means the row of A with the column of B. So that's why we need this to be the same. That's why we need the column of A to be the same with the row of B, so that the size of our multiplication of our product will now be m by p. That will be the size. Okay. So, for example, A is given as 1, 2, 0, 3, 1, 2. B is, okay, so what's the size of this? That is 2 by 3. That is the size of this. Now, B will now be 2, 1, 0, 2, 0, 3. Okay. What is the size of B? The size of B is 3 by 2. Okay, if I now want to do the multiplication of them, 2 by 3, 3 by 2. If I want to do the multiplication, is the multiplication defined or not? Let's check. The column of A is the same thing. The number of column of A is the same number with the row of B. So this operation is defined. So we can find the operation. If they are not the same, then the operation is undefined. Recall, when we're doing addition and subtraction, the only condition we need for that one is that the size must be the same if we are doing addition or subtraction. So if the size are not the same, the size of the two matrices are not the same, then the operation for addition or subtraction is undefined. Now for matrix multiplication, the only condition that is undefined is when the number of the columns of the first matrix is not the same with the number of rows of the second. Okay, so now I give you this. I will give this B multiplied by A. I'm multiplying B by A. What is the size of B? 3 by 2. What is the size of A? 2 by 3. Is this operation defined? Yes, is defined because the number of row of column of B is the same as the number of the row of A. So this is still defined. This is still defined. Sometimes they may not be defined. This is still defined. So we are lucky to get this one to be defined on both sides. But in most cases, AB, that is A multiplied by B, is not equal to B multiplied by A. Of course, the answer you get will be different, but sometimes this might be defined and this undefined. This might be defined and this undefined. Okay, but generally they are not equal. Even if both of them are defined, for this one now, the answer I will get for AB, the answer I will get for AB should be 2 by 2. That is my answer for AB. But the answer I will get for BA, the answer I will get for BA will be 3 by 3. You see, so they are not the same. They are not the same. So any property that makes them to be the same is a special one, is a special property, okay? But for now, they are not the same. And sometimes this may be defined, but this one undefined. Or this may be defined and this one undefined. Okay, having said that, let's now multiply these two matrices together and see what will be our answer. We want to multiply these two matrices. We know that this one has the size 2 by 3. And I know that this one has the size 3 by 2. And I know that when I multiply both of them together, the size of the multiplication of the product should be 2 by 2. That is very important. It's very important to know the size you are going to get later, because that will help you in your multiplication. So I want to multiply A and B. That will now become 1, 2, 0, 3, 1, 2. Then I'm multiplying with B, which is 2, 1, 0, 2, 0, 3. Please, when you are multiplying two matrices, put them side by side together in order to have your multiplication nicely and correctly. Now, when we are multiplying two matrices, we multiply row of the first one with the column of the second one. Row to column. So I start with this again with this until I finish the columns of the second one before I go to this one. So this one with this one with this. Okay, so let me go. 1 multiplied by 2, 2. 0 multiplied by 1 plus 0. 1 multiplied by 0 plus 0. Okay, that is for the first one, and that is for the first column, first row, first column of our product. Now this one again and this one. 1 multiplied by 2, 2. 0 multiplied by 0, 0. 1 multiplied by 3, 3. Okay, let's go for the second row now. This multiplied by this, 2 multiplied by 2, 4. 3 multiplied by 1, 3. 2 multiplied by 0, 0. Now the second row to the second column here. 2 multiplied by 2, 4. 3 multiplied by 0, 0. 2 multiplied by 3, 6. All right. So after that multiplication, and then I get my addition. This is 2. This is 5. This is 7. This is 10. So you can see we have our 2 by 2 matrix. Please, this is very important. Ensure that you understand.